good to be here. I spent many years, as you heard, doing research and focus on the academic side. The last 5 years has been how do we actually make these things useful. And the way that I got into the sort of safety and reliability space, like not being the next headline is a very marketing thing to have in a title, but I'm a very academic person in my background. It's like, how does that happen? And over I had the same problem. So when I was at Microsoft Research, I had a problem with cheating detection, and machine learning models didn't work because the labels are really noisy for cheating detection. For example, how do you know for sure that someone didn't cheat? You actually never really know that someone didn't cheat. So there's a lot of false positives, false negatives when the machine learning models were training on the data. And it turned out that ML actually doesn't work very well for cheating detection. So I spent 3 years on that, realized that noisy labels weren't solved, spent the next 5 years inventing what's called confident learning, which is a rigorous framework with provable guarantees that I worked on with the head of AI, Lu Jiang at Google, for noisy learning, and also with the inventor of the quantum computer, Isaac Chuang, who's my PhD advisor. And until about 2021, we had gotten to a point where we had solved the problem of if you take an arbitrary data set and you feed it to a machine learning model, and that data set has a lot of noisy labels and errors in it, that you can rigorously and with provable guarantees find a significant portion of the errors in the data on their own. The data can automatically find that within itself using other machine learning models. Then you can fix the data, remove those errors, and retrain a final model, and you can actually get significant performance increase. So that's where we got until about 2022. Then ChatGPT came out, and everything was not about training anymore. It was about RAG and agentics built directly on these LLMs and RAG. And so we've had a pretty long journey to get to what I'm going to show you today. I'm going to show you two things that I think are pretty unique to Cleanlab. One is we have the most accurate ability to detect if the output, the logits and the outputs out of an LLM are incorrect or not. So not some like helpfulness score, or is it in context, or some, there's a million evals, but actually just like, is it the right response for a given prompt? And the second thing that we do that's pretty unique is we have a way that you can actually directly influence and fix and control the outputs of a machine learning model, specifically agents built on LLMs. So that's what this talk is about, is how do you control these things, both at the detection observable layer but also at the controls and safety layer. So I think we'll skip the background, but we've been doing this a while. We have a bunch of real enterprise customers, happy to chat about that, at our booth, and our booth is right over there, right next to the snacks. But this is a company that's founded out of MIT with a bunch of PhDs from MIT. Those are two of my best friends and co-founders. So this is showing some news articles that are like pretty hot ones that people know about. For example, Air Canada promised a customer that they would refund them, but it wasn't Air Canada, it was the branded agent that speaks on behalf of Air Canada, an AI agent. And of course the customer said, hey, look, you've told me I can have a refund. And once that happened, the customer was able to sue them and won. And so legally Air Canada had to A, sort of be embarrassed by this AI agent, but B, they had to also pay them. The New York City chatbot, if anyone's tried it, does all sorts of wild things. This is one that it does, but also it's told people to eat cheese that's been bitten by rats, and many other obscene things. Built is a great example of a company that partnered with Decagon to have an end-to-end customer support agent built. And within a few months of that deployment, it told all the customers that it doesn't work with Apple Pay. And so you might hear that and think, oh, look, we can, that's something once it's detected. So first of all, like, how do you detect that? That's even going wrong. In their case, they detected it because it went viral on Reddit. So not ideal. But secondly, like, how do you patch it and fix this thing once it's been detected? And so in their case, it took them several months. And so on Reddit, they continued to go viral because this continued to say an error. But if you think about actually trying to solve this problem, you would need an ML team to actually fix the RAG system, find the search, fix the problem. So there's so many problems in these systems. It's like, how exactly do you fix that very specific output? And so I'll show you how we do that. There's a few other ones, Cursor being the most recent one. As a quick show of hands, who saw the Cursor article? Like, what happened to them? Yeah, it's a bummer because Cursor's a great product. And if you haven't seen this article, it is worth checking out from Fortune. The New York Times also recently covered this just a month ago, where Cursor literally just told everyone, like, you can only be signed in on one account at a time. So these are the types of things that we solve at Cleanlab and prevent from happening. And just to show you an example of that, if we go into, this is a quick demo, which is asking exactly the question that is in the New York Times article and the Fortune article. And we have a RAG system that we build for customers, but the main thing that we're providing is that control and safety layer. And this is a question that was asked that's shown in that Fortune magazine. Can I only sign in from one device at a time? And this is the response that was given because we just built a RAG system on the exact same documents as their agent. So this replica is reproducing that error. And what this is just showing you is there's an API in the background. So this is a demo. This isn't the product. This is a demo. We're an infrastructure AI company. So we have APIs in the back end that are checking every response. And then they're telling you in real time whether or not there's a problem. So in this case, what actually happened to Cursor is something that Cleanlab can detect automatically in real time, like 300 milliseconds. And had they been using Cleanlab at the time, they would have never ended up in the news. In this case, they just didn't grab the right context. And so I'll show you how this works in a second. But we have a safety layer that allows you to control those outputs. And I'll come back to how we do this. But had they used Cleanlab, it would have said something much more appropriate to what they wanted. So going back to the slides real quick, if we take a look at there's all sorts of things that we could cover. This is an example of a very common chatbot a lot of people have probably used that over $10 million was spent on. And it has 3 different types of issues. So it has missing answer, wrong context, and hallucination. There's too much on here to read, and we're a little bit tight on the time. But the key idea here is that there are multiple sources of error. So I just want to emphasize that when you're trying to make these things controllable and reliable, you have to deal with users that are sometimes antagonistic or doing prompt injection, but you also have to deal with the fact that the models will hallucinate, especially multi-reasoning models, because there's multiple steps where they can add error in. And there's also search issues where you grab the wrong context. And there's also data issues where there's an error in the context or the context is missing. So all of that is being fed into these systems to produce these errors. What our platform is doing is disambiguating what the root cause analysis is and then providing a way for you to control it. So high level, these systems are unreliable to deploy, and you can actually think of there's a lot of parallels between what network security is like and what LLM security can be like. And so I just wanted to show, before I jump into a demo, I just want to show a quick example. It's a bit hard to see in this lighting, but this is Unify. This is a network. This is not our product. It's just a screenshot from my home network device. And all it's showing is a world that I think we are not very far away from of how we can control and make LLMs and agents safe. And so I just wanted to highlight that what you do, if you could just identify what the issues are, you could block that type of response from ever happening. And the moment it's clicked, that should never happen again. And we've seen this paradigm before. And this is the paradigm that Cleanlab has created in the agentic world, where you can think of network traffic very similar to agent communications. And you're checking every single communication and where it's going, and you're grouping them together in types of issues that are occurring. And then you click on an issue, and you can block that issue and say, hey, look, these are the things that I don't want to have access to that issue. These are the users that should get this type of communication. So I'll pause there in terms of the slides, and let me just show you really quickly what that actually looks like in practice. So this is an example of we've abstracted the company name and removed everything, but this is actually real data that's in a real production system. And our customers are bigger customers. So these are folks like Apple and Deloitte, American Express, ServiceNow. And this is from a major customer service provider. And what you're seeing here is a bunch of different queries that have come in. And that 5 means that something like that has happened 5 times. This is not intended to be demo perfect. This is actually real data. So people are just doing weird things with people's chatbots, trying to screw them up. And what you'll see is that we're automatically grouping these together and putting them into these groups that when you click on one of these groups, so let's click on one real quick, you can immediately type a quick thing that says if you see an issue, contact, whatever. And you hit submit, and that's it. So it's just, the moment that, I won't do this. I mean, you can see it, it's fine. But the moment that you've done this, it's just like that block. So you now have blocked the AI from any response, and it will now produce a remediated answer that is actually what you want, that is compliant with your company's business. And so we're handling the evaluation layer and the detection layer, and then we're also handling the way to actually control and add safety to the outputs. And this is different. We don't know of any other product that's doing this, especially in the customer-facing support area. And this is all we do. So we're just that layer that must have to get these things into production, where they say the wrong thing, and now you have a way to remediate them. And as part of this, there's a lot of features of the platform. We're detecting, for example, what is the root cause analysis? Is this because the response is not grounded in the context, or the context was wrong? Is it a hallucination issue? Or is it actually just that the query is like really difficult to handle? An example of that would be like he gave him his item. It's like who exactly got what? And so there's a lot of different types of uncertainty that we're measuring as part of this. But the key value that this ends up being is that you can now actually control the outputs of the system. And what that ends up looking like is all sorts of integration. So I'll show you a couple more things and then I'll end. This is an example it's a demo of like an integration with Jira ticketing platform for a customer that shows like if you have one of these issues while we're fixing it on our end, you might actually want to fix the root cause as well. And so what this is doing is providing step-by-step ways that once an issue is detected, you have the root causes in the document so that you can directly go to the document and fix the issue. And this is something that comes up a lot where it's one thing to sort of patch something and like have a bunch of network protocols that prevent it from saying the wrong thing. But often people also want to fix the documents at the root cause. And so we're also linking to the individual documents. I'll pause there and just see if there are any questions. And that's like 1/10 of the demo, but given the time constraints that we have.